This one's for the nerds. If you like geometry, stick around. We're going to go over how window shading is calculated. First, let's go over this schematic and define the key variables. We have a window in red. We also have two types of shadings. There is an overhang and there is a side hang. The overhang is going to give you top down or vertical shading, and the side hang is going to give you left to right horizontal shading. So variables, there's the window area. H for height of the window and W for the width. To define the top overhang, we need to know the depth and the offset. So we're going to use the variable pH for the depth of the overhang and RH for the offset. Depth being how far out the overhang goes, offset being how far from the top of the window the overhang starts. For the side hang here, we're going to have similarly the depth, which is PW, and the offset, which is RW. All right, now we've defined all the geometries of the window and the shading components around it. Next, let's put the sun in the sky and define some more variables. So with the sun coming down, these shading components are going to cast a shadow on the window. And you'll see here, this top overhang is responsible for really this top portion of the shadow. And then the side overhang is contributing mainly to this portion of the shadow. And you'll notice part of the window is shaded and part of the window is sunlit. And that's what we're trying to solve for. We want to determine the area of the window that is shaded, which is ASH, and the area of the window that is sunlit, or ASL. But we need some more information to get there. So let's define the geometries of this shadow. The height of the shadow right here, made possible by this top overhang, is going to be our SH, shadow height. The width of the shadow, made possible by this side hang, is going to be our SW. Okay, more variables. Last piece. In order to solve for these shadow geometries, we need to know exactly where the sun is in the sky. And this is where we take it up a notch. Look closely right here. This angle that I've drawn up, represented by omega, this is the profile angle of the sun. It's relative to the top overhang here coming straight down and then going across horizontally. This angle over here that I've drawn up is relative to the side hang. This is the solar surface azimuth of the sun. I'll speak more about these angles right now as we get into the equations used to calculate the shading. Here are the steps to solving for the sunlit area and the shaded area in your window. First, we need to find the profile angle, omega, here. You do that by taking the tangent of omega is equal to tangent of beta, which is the solar altitude, divided by the tangent of gamma, which is the surface solar azimuth, as I mentioned before. These variables, solar altitude and surface solar azimuth, are calculated using latitude and longitude of your project location, the time of day, and the time of year, accounting for daylight savings in certain places. Don't worry about all this. It's pretty mind-numbing to get into. Just thank your favorite load calc engineer and any software developers involved in building programs that calculate this for you. Just consider it various angles of sunlight. So what do we do with that? To calculate the geometries of our shadow, first we're going to find the shadow width, which is calculated by taking the side hang depth, PW, and multiplying it by the tangent of gamma. And as you can see in the diagram up here, we're really solving for the length of this line right here on this triangle. Pretty cool stuff. But next we're going to use the overhang depth, which is this dimension right here, and we're going to multiply that by the tangent of omega. And really we're solving for this, which is equivalent to this, our shadow height. Awesome. That's the most difficult part. Step 4, we're going to solve for the sunlit area. So really we're solving for an area here, width by height, but we're going to adjust for the width and the height by the shadow width and also the offsets. Then we're going to multiply that by the height of our window here minus the shadow height minus our top overhang offset right here. That will give us the remaining sunlit area right there. Now to solve for the shaded area, we're going to take the area of our window, just the width times the height, and subtract the sunlit area that we just solved for. And that will give us our shaded area. Once you know the shaded area and sunlit area of your window, you can then accurately calculate the solar load for your window.